This is problem number 13 from chapter 6. So we have several questions referring to this one problem over here. Patient recovery time from a particular surgery procedure is normally distributed with a mean of 5.3 days and standard deviation of 2.1. What is the median recovery time? Well, what's important to note here is that if you have a bell-shaped curve, and we know that the mean is going to be 5.3, a symmetric curve will have the mean and median at the same place because it's symmetric. If it's skewed, then the median would be somewhere close to the middle and the mean would be moving towards wherever it's skewed. So the median should be, if not exactly equal to, it should be pretty close or approximately equal to the mean. So the median would be also 5.3 days. The next question, what is a z-score for a patient who takes 10 days to recover? So remember that the z-score is the number of standard deviations away from the mean. So if 2.1 is a standard deviation, 5.3 plus 2.1 is 7.4. 2 standard deviation, if we add another 2.1 there, it'd be 9.5. And 3 standard deviations would be another 2.1 here, so that would be 11.6. So this is 1 standard deviation, 2 standard deviation, 3 standard deviations. So it looks like 10 would be sitting between the second and third standard deviation. So our answer here should be about 2 point something. We can get the exact value by using a formula for the z-score. The z-score is going to be x minus x bar, or mu, divided by the number of standard deviations. So if we're looking at 10, our mean is 5.3 and our standard deviation is 2.1. That's just a matter of putting this in our calculator. Now we just have to be careful with our calculator in that if we do the numerator first, we can't just go from here and divide by 2.1. If you do your calculator work like this, the calculator will take 5.3 divided by 2.1 first, and then 10 minus that. So a way to skirt around this is to delete this part, and since we're pretty quick at using the calculator, we can just hit enter here and then hit divide by 2.1, and that'll give us our answer. The other way to do it is to put 10.5 minus 5 10 minus 5.3 in parentheses, divide by 2.1. So we got our answer to be 2.238. Usually z-scores are rounded to 2 decimal places, so it depends what they're asking for. The next one is, what's the probability of spending more than 2 days in recovery? And so the probability that somebody spends more than 2 days in recovery is going to require us to find area under the curve or use a normal CDF. So 5.3 is the mean. 2 is somewhere less than that, and it's going to be all this area to the right of that, so it should be bigger than the half. This is our notation, probability that x is bigger than 2, and our calculator command will be a normal CDF, and then this is going to go with a low of 2, a high of infinity, and then the mean, and then the standard deviation. So we punch this in our calculator by going to second function in distributions, or vars. Normal CDF is the second one, and then we get 2 comma, and then the 1, the E, remember, is right above the comma to the 99, and then 5.3, and then 2.1. And we get, looks like it's a pretty good probability. That's 0.9419, or round off to the fourth decimal place. That would be 9420. The last problem here, the 90th percentile for the recovery time is how many days? So you got 5.3 here, and the 90th percentile would be somewhere over here, where this is 90%, and so this is 10%. Has an area of 0.1, and you want to know how many days is going to go fall in there. So notation will be a probability that x, well, let's use the less than symbol because they're talking about the 90th percentile, or 0.9. And so what value of x are we going to have so that we're looking at the 90th percentile? If you remember, that's going to involve the inverse norm, so the second function in vars, or distribution. Inverse norm is our third option here in our calculator. And then remember that this is looking for the area to the left, which is going to be 0.9. This is the area to the left here, 0.9. And then we punch in our mean and our standard deviation, and then it's going to give us 7.99, so basically 8 days. So the recovery time, the 90th percentile for recovery time is 8 days. Alright, I hope that helps.